Hello, everyone. Welcome to another episode of Pints with Ayre. I'm Brent Heffley, Sales Marketing Director for Ayre Acoustics. With me, as always, is Ariel Brown, our VP and Senior Engineer, and Ryan Berry, our CEO and Expert Technician. Cheers, everyone.
Cheers.
We've got some fun stuff today, but let's start off with beers today. I ventured out, and you know how I'm often a label guy. So this wasn't as much a label person as purchases a recommendation at the store, because I had never heard of Little Beast Brewing before, even though they're up in Portland. This is their Pine Top IPA, and it has this really interesting, nice touch of pine, as you might imagine, to it. But it's a great IPA, nice color, very crisp and refreshing for fall weather like we've got here right now.
Nice.
What did you guys find in the old refrigerator there?
So another Colorado brewery, which it was a lot to go through. So
Yeah.
Excellent.
Telluride Brewing. It's in kind of the other corner of the state, but they make some fantastic beers. This is
Nice.
Beaver Pond Blonde. It's a Belgian style blonde ale. It's pretty tasty, a little bitter, but it's really tasty.
All right. Awesome. Beaver Pond Blonde. Gotta love it. All right. Well, our audio topic today is RF, radio frequencies, how they affect your audio gear, and what we try to do about it. There's a lot of different stuff out there. I mean, I have my own special tweak for that, just to protect myself while I'm listening from anything that might be radiating in through the roof. But
You wrap yourself in the tinfoil?
Yeah, little. It's, it makes the system sound a little tinny, but I have to put up with that for safety's sake.
But you're no longer microwavable.
But I'm sure we have some more effective ways to deal with RF. So
I certainly hope so.
Why don't we start off by just talking about how RF can affect the circuitry and affect the components in one of the pieces of gear?
Right. Yeah. So as we touched on last week, talking with Jim about transformers, one of the even just in everyday life now, we see that there's more and more essentially RF noise, beaming into our houses.
Right.
And so as well, and also particularly on the power lines,
Right.
because the power lines act as one big antenna, so that just conduit into our audio gear.
Right.
And so as Jim had told us, one effect of wireless is that it actually affects the transformer itself. It can actually help saturate the core of the transformer, so it's not operating optimally. Besides that, the actual RF noise can actually be picked up by the analog and digital circuitry, and has various effects there. Besides just potentially increasing the noise floor, can actually affect pollute actual signals that you want to be pure, and actually affect the digital conversion, the actual analog signal everywhere. It just that high frequency noise has a myriad of effects that can be hard to quantify, but it's definitely audible.
And I'm sure it's compounded too. Like if it gets into your source component and that gets fed into your preamp and amplified at that point, and so on and so forth, you can that can be true. I mean there's certainly bandwidth limits of the analog circuitry, so it's not necessarily going to amplify it, and it'll probably pass it to some degree. Again, there'll be some attenuation, but it's not necessarily part of the signal there, so that's being conducted at that point, and so it's it can certainly pass on down the chain. Right. So it comes in. We've got it coming in on the electrical lines. You know,
Yeah.
it may be also be airborne if you have a Wi-Fi router that's close to your system, which could go into the power in your house, but also maybe directly in through the components. Although I think the chassis do a reasonable job of shielding that direct transmission.
They do some, yes. Yeah, they definitely they attenuate it. You know, there is no such thing as 100% blocking,
Right.
But it can attenuate it.
Yeah.
Sure.
Yeah.
Right. So yeah, so we, you know, one of the main methods we have of, you know, of trying to block that RF, certainly on the power line, is you know, we have some AC power filtering.
Mm-hmm.
So in the early days of Ayre, you know, we tried, and we're happy with initially. We had some ferrite, some ferrite rings that we would wrap the transformer primary around.
Right.
As it connected to the AC power plug, and we were happy with that for a while until we realized that it mysteriously wasn't sounding good anymore. And then we found out that you had to degauss, you had to essentially demagnetize the ferrite ring, and then it would magically sound better again for a while, and then it would slowly deteriorate. And so it was not a consistent effect, so because the ferrite becomes magnetized.
Mm-hmm.
So we had to get rid of all the ferrite. So Charlie worked on. He came up with an idea to try and do the same thing that ferrite does, but in a non-magnetic fashion, so it would be, you know, a consistent effect that would not change over time.
Uh-huh.
So we can what we call the air conditioner, and physically, we have some various versions that we use in some of our products, and it's very similar to the ferrite in that it's a completely passive, and I almost call more of a kind of a parasitic effect, because it's not in series with it. We're not interrupting the actual primary conductors. It is just sitting essentially next to them, and so it is basically, you know, it's basically trying to remove some of the RF and converting it to heat with some passive elements that the wires wrap around.
Right.
That's what it tries to.
So we're taking that RF that's on the incoming line, and we're converting it to heat energy and dissipating it that way.
Yeah.
To keep it from infecting the rest of the circuit.
Right. Yeah, and we found that works great on the audio gear. I remember some of our very early tests. We even put it on the power cords of some of like a TV, and it even improved the video quality of just a basic TV in the basement. Yeah. We were really surprised.
Right.
So it definitely has an effect.
Right. And we made a product, the L5, which had 4 inputs and was RF filter. I have a couple here at home. I'm sure you guys do too. That was great because as you said, it attenuates it, so it takes out a chunk, but nothing's going to take out 100%. So if you put them in series, you can actually reduce that even more.
Right. Yeah, and it's kind of interesting because we've had cases where, you know, some people put 2 of them back to back, which was something we had never done, and, you know, swore there was improvements, and then adding a 3rd one seemed to take away from it. So it's a little bit of a balancing act. It's kind of hard to say where the right point is, and I think houses kind of vary too. So
yeah, I was going to say your environment definitely has an impact on that. How much?
Yeah, exactly. You know, somebody living in, you know, Detroit might have a different power supply than somebody living in Texas, you know, so to speak, or Dallas, you know, so to speak. So, you know, they might have various results. So it's a little bit of experimentation when it kind of comes down to it on where that sweet spot is, I think.
Sure. I think it's safe to say now, though, that it's virtually impossible to find a house that doesn't have RF coming into it.
For the RF, for sure, you know, and that's definitely something you're not getting away from. I mean, you have power lines outside, and they come into your house through the transformers, and, you know, there's no getting away from it. So
right. I mean, maybe if you went completely off grid, total solar.
Yeah. Well, even then, I mean, I'm even with solar, you still have to have inverters to then regenerate the AC.
Yeah, and
So
it's
even
gotten to
that's
be
gonna
more.
create great noise.
And it's been gotten more popular with the solar panels that instead of having a central inverter, each panel has its own inverter. So now you have 27 solar panels, you have 27 inverters all running at the same time on your solar system. That's actually what I have hooked up around my house. So,
Right.
it's definitely not the cleanest of power coming in even then, even though
Yeah.
you'd think it would be.
Right. Right. Yeah. Very, very interesting. Maybe when we get to the Tesla powered houses, but still, there's always going to be something.
No, I mean, you have to convert everything to DC, I'd imagine, and run DC off of everything. Good luck.
Yeah, and then say, trying to see if I can find an example, so that even on our board level, so that oftentimes we have some miniature air conditioners, as we call them, even at strategic points within the DC power supply. And so I think, so see one on this board here. So we have a little mini air conditioner, it's a little wire wrapped device here. So that's one of our little miniature air conditioners that we place within the DC power supply path at critical points in some of our circuits.
Yeah.
And I won't lie. I mean, the air conditioner, as we fondly call it, was one of those pieces of technology. I'm like, okay, it's like, all right, voodoo, and didn't really buy into it, and it took me doing some A to B listening before I was really convinced, and that was something that took me several years of the company before I was finally willing to just sit down with it and see, what's all about this, because I was convinced it didn't make any difference. And
What, you a skeptic? Come on.
yeah, weird. Not allowed to be a skeptic in the high-end audio industry, right?
Right.
But no, I mean, it was definitely a place that I had a hard time accepting it, and it had to be proven to me. And I gotta tip my hat to Charlie and Ariel, because all this stuff, it ends up making sense, but it can be hard to understand how this little block with wires wrapped around it is actually doing the things that it's supposed to be doing. And but once you hear it, it does make the difference.
For sure. I mean, one of the things it was always super impressive is at shows, because you're going into a hotel that's just loaded with electrical crap and stuff on the lines. It's amazing. And we plug the L5s in and the system into it, and there's a significant difference there, probably much more than you find in most houses.
Oh yeah.
Yeah. The other great use for that L5 is such that even if you have digital sources or any kind of sources that have like switching power supplies, to actually have them not necessarily to clean them up, but to block their contamination of the power line that feeds the rest of your gear.
Right.
So I mean, I know that we're filtering noise as heat, but I mean, it might be a good discussion to have on like what specifically is it doing with the AC coming in. I mean, you have an AC sine wave, right? And that's coming in and it's going through this filter. Now, what is the filter specifically doing? I know it's converting noise to heat, but is it catching transients, or how does that?
This this thing is simple. That I know it will not alter waveform of the it. As far as transients, it might take the edge off a teeny bit, peak down, but only if it's really, really high frequency. And so it's really mostly filtering, particularly high frequency noise,
Okay.
which a transient will have some, and so it will reduce some. But it does not designed and not capable of actually suppressing any kind of serious transients.
Right. So I guess that gets me to the next question, because there's two ways to really handle a lot of filtering, and that, well, AC I should say, and that's a filter, and then the other option is the popular regenerators that are out there. And I know that a regenerator is supposed to take the incoming AC voltage and then break it down to DC and then put out its own perfect 120 volt sine wave.
Right.
But I know that we've also listened to those things and we've had different results than what has been advertised in a lot of cases. So what's your take on those?
Well, yeah, our experience is, is that they've always been a detriment to the system. We've never seen a case where they have improved our system, and so any of our passive filtering is generally an improvement. Why that is, I can't say for sure. I don't know if it's just a matter of their output impedance, or they're just not capable of ultra low impedance, or because they work with some feedback mechanism. I don't know.
Mm-hmm.
I really
so effectively those regenerators are kind of an amplifier, aren't they?
Yeah, it has to be an amplifier.
Yeah, so it's effectively putting an amplifier in front of an amplifier or whatever in your system that you have. And so I guess it kind of comes down to the same rules as any stereo product, where it has to be very specifically designed to work right. And then you've got that, and you're also dealing with, oscillator in of itself is effectively a noise source that's on the circuit to generate that sine wave. And yeah, I guess that makes sense. I can see how, while the ideal perfect output sine wave would be something you'd covet, when in practice it might not be something that is quite as nice sounding as it should have been.
Yeah. There's quite a few factors there that it's really hard to say what the dominant one is.
Now, for anybody listening, this is kind of one of those cases where we definitely don't try to script our videos ahead of time. This is where it's about discovery for us. This is a lot of what we do here is an organic process where we talk about audio, and we try to discover new ways to do things too. The air conditioner is a great example of this, where we started with a design and we've been using it for a long time, and it wasn't until the 20 series came out where we revisited the air conditioner, and Charlie's like, oh, there's a way to make this way better. And, we altered the design, and, that started showing up in our products after that. So, we're always growing, and it's not about, well, we don't do it, so it's not as good. We like to explore these things, and, having these discussions is important to us as a company too, because until we do have these discussions, we will never grow. So, it's a fun process, but it's all about learning all the time.
Yeah, absolutely. And it's something that no one really has the complete answer to.
Mm-hmm.
Anyone who says they do is just trying to sell you something.
Well, that's one of the frustrations in the industry too. It's so hard to, the conceptual level of a regenerator, for example, like conceptually it should sound perfect. It's putting out a perfect sine wave, right? So it should be the perfect power solution in all cases, and there should be no way to make it sound any better. But empirical evidence in our case, and from many customers, I think one of the rules of thumb is people generally don't put regenerators in front of amplifiers, but they'll put them in front of digital products, for example. And why that is, on paper it shouldn't make sense, but clearly once you try it, that's the way it ends up working out. So. The questions come down to why that is, and that's high-end audio in a nutshell. There's numbers that we can chase all day long. You have THD numbers and wattage per channel, and distortion levels and jitter and all these things. But looking at just those numbers in a magazine doesn't tell you what a product's going to sound like. It's not until you really get it into your home and you get to actually experience the unit that you really learn anything about it. It's the frustrating thing, but also the fascinating thing about the industry.
Yep. Long-term pursuit of perfection.
Absolutely.
Yeah.
So on that note, we're always looking for new ways to do things, of course, and power is one of those factors that's kind of close to me personally, because as talking to Ariel about this, we can do everything we want to try to make the system as perfect as possible. You have fantastic components in your system. You get the super cables to put in your system. You buy that very expensive set of speakers, and you get everything dialed in, you treat your room as best as possible, but you're still dealing with that doggone Romex in your walls that is built by the lowest bid contractor, and it's not designed for high-end audio. And what do? Do you go through and tear out every line in your wall and then start talking to the power company about making a better sounding transformer and their step down transformer to your house? And where does it
about
end?
the stuff you do.
Yeah, but where do you end? I mean, you can chase it all the way back to the power plant, and then, same with, Ethernet. You have your Ethernet cables, and we have these high-end cables that we deal with, but then we feed them into standard switch boxes, or those go out to a post running, the cheapest coaxial cable that the cable company can get a hold of. And, those are things that we can't touch. So, finding solutions to be able to, brick wall those or treat those in a way that, it's impossible, well, pretty much impossible to brick wall them entirely, but, find a way to treat those as much as possible to keep that link in the chain, that weak link, so to speak, in the chain from getting into your system, is a real important piece of technology. And it's something that's always, I think, going to be one of those places where you continue to want to evolve, because as we know, the world's evolving around us, and we're having to deal with more and more problems that is coming from those sources. So it's a really important key bit right here. So I know that we've kind of hammered the whole power into things in the last two videos, but it's a big topic, and I think there's a lot to be gained from it.
Yeah, it's not a static problem, as we know. Just as more and more RF is essentially generated in the world around us, it is not a static problem. It is an ever increasing in amplitude, and so moving forward, we can't be static in the way that we try and address that. So we need to keep on moving forward and trying to deal with that increased RF.
Yeah,
and trying to keep it
absolutely.
out of the year.
Absolutely. Great. Well, I think that's a good summation of where things are at with that. If you guys out there listening have things that you've tried that really work, things that you've seen that you're curious about, email us at pints@ayre.com. We'll be happy to take a look at that, answer it with our thoughts, and until next time, cheers.
Cheers.